computer. So now here comes the lecture on future forecasting, trend forecasting, all those things. So like I said, we in industry are pretty much forced to know what's going to come because we are working towards that, right? I mean, everything we develop as engineers, as designers, is stuff that is going to be used in the future. And depending on what it is that we're developing, it can take a long time or a short time. But the fact is that most good products have a lead time of at least a year. In the car industry, it used to be 7 years. So you need to know a lot about the world that is about to come if you really want to make your product right for it. And all sorts of theories exist, of course. The further into the future we go, the less certain we can be about how it'll be. We have all these wonderful utopian visions with flying cars and earth homes that use geothermal energy. We have some of these which tell us that population is building up and up, which it isn't, by the way. If you've ever read the work of Hans Rosling, who has proven that actually population growth is going to slow down a lot and eventually plateau. We have these ideas also that perhaps there's going to be another ice age, or the opposite, it's going to be global warming and it'll be just too hot for anyone to maintain any sort of semblance of civilization. We also have this scenario, which is from the movie Waterworld, the old movie now, but it shows a film in a world where everything has been submerged in water because of all the melting ice. So all of these things are totally possible. I personally think that Stephen Hawking actually has it right, and that eventually we are going to colonize space because we can. I mean, when you're looking around this planet, there is no other species that is able to go into space, build spaceships. I mean, I don't know what my cats do at night, but I really think we humans are the only ones on this planet that can build spaceships. And I think the thing with biological creatures is if they can do something, they're meant to do it. And we're meant to build spaceships, so we will and move away. And then there is another thing we can do that we haven't even fully embraced yet. Here we see a strange earth creature from a fantasy novel. And I believe that we have possibilities to change our bodies and to change what it means to be human so that we can fit an environment. That's probably also part of the whole space colonization thing. But could it be that maybe a portion of us is going to stay here on planet Earth and change our bodies and how we live so that it actually fits with this planet? I mean, again, when you look at us, we are the one species on this planet that doesn't seem to belong here entirely. I mean, if we aren't wearing clothes and if we aren't using fire, we don't live very well and very long. So something about the way we are set up isn't perfect, but we could perhaps with some bioengineering turn ourselves into creatures that can eat raw anything and fly and jump like tigers and who knows, you know. But I think that is another future that we may well have, that bioengineering takes us a whole step further into being more in tune with planet Earth. Now, a lot of people have tried to predict the future, and some of them did it in esoteric ways, which I don't think very much of. And then others have been trying to do it in a technically informed way, like Isaac Asimov, for example, who, despite his name, is actually American, not Russian. And he was given a challenge by some journalists in the 1960s to predict the world of the future. He's a futurist, right? Isaac Asimov is one of the most famous science fiction authors, always describing the future and the things that we do there. So when these journalists came and said to him, hey, tell us what life is going to be like 50 years from now in 2014, he gave them a pretty long list of predictions that what he thought the world was going to be like in 2014. So let's go through these for fun. He said that by 2014, appliances will have no electric cords, but they will be powered by batteries running on radioisotopes. So he was basically predicting nuclear vacuum cleaners. And well, I have a cordless vacuum cleaner, but it's not nuclear. It does have a pretty good battery though. So halfway there. He predicted that the cars of the year 2014 would be like this. No more wheels. We're just flying around. They're basically airplanes. Well, some people are still trying, but we can tell that your average car isn't like that. The background meowing is from my cats. Nothing to worry about. They're fighting. They sometimes do that. We also saw this. Moving sidewalks in the cities. You no longer have to walk. You just stand there and it takes you there. Well, again, not entirely true, but when you go to an airport, you see these things. Moving sidewalks are definitely true in airports. Then there was the whole idea that we should all be living underwater. Nobody really fully understood why, and it's not happening, but this is how he imagined we would be living a lot in this day and age. But personally, I think this could be a very clever thing to do, because when you have an underwater home, you're basically in a very still place. It's quiet, it's perfectly insulated. You have a very steady temperature year round. And if there is flooding and if there is hurricanes and stuff or tsunamis, no problem. You're already down there, right? And dealing with it. So why not embrace it and make use of it? Then there was also the whole idea that we might be no longer eating normal foods, but something much better than that. Inspired by astronaut food, he figured, well, of course, if you can put it into a pill as an extract, it's going to be so much more powerful and so much more convenient to eat and prepare. We just swallow pills. And thankfully, that hasn't happened. On the contrary, we've never been more interested in cooking than we are these days. Another interesting one was that he thought our days and times would be incredibly boring because nobody would have anything to do anymore. All the work is being done by robots. So you just hang out with your homies and watch TV all day. And that's the life challenge. So that's also not entirely true. Unfortunately, I quite like to live like that, I have to admit. But he wasn't all wrong about everything. He also got a few things perfectly right, and that was pretty amazing. So he predicted all these things here on the right perfectly correctly. He predicted GPS, something like Skype, cars that can drive themselves, smart kitchens like we have, smartphones even, satellite communications, which were really nowhere near even talked about in 1964. Cars that could park themselves, like my Toyota Prius, flat screens, and drones. So quite amazingly, for a guy over 50 years ago, he got these things absolutely right. And he isn't the only one. There were other people who had some absolutely accurate visions of the future. Jules Verne, the French science fiction author #1, also in terms of #1, also #1 in terms of actually being the first science fiction author. No one before him had thought of writing stories that are placed in the future, making use of technology that didn't exist yet. He did. And in the 19th century, he gave us quite a few stories that continue to influence us today. Among his stories were, for example, a trip to the moon. So he described how scientists would build a spaceship that would be shot into space like a cannon or like a cannonball. And then it would look like we see here on the left, and basically like a little choo-choo train that goes to the moon. And he didn't get all his facts right. They didn't know, for example, that there was no air between moon and Earth. So they had some passages in the book where the scientists who are doing the trip are going out to the back balcony for a smoke, sitting on the balcony of their rocket, having a cigarette. So that wasn't entirely right, but he got a few other things right. I mean, we're seeing here the American flag, so he got it right that it would probably be the Americans who send out a thing like that. And it's also interesting that we see the capsule here on the ship deck returned from the trip, which is, of course, exactly what happened. And when you're looking at what they did in 1968 and 69, when they did send rockets to the moon, you actually had exactly that setup. You had a modular setup here of an actual Saturn rocket. And then they came back just with the top capsule that plunged into the ocean. So it's really quite remarkable how he got that right. Jules Verne also predicted that we would have this, the ability, this is my wife sneezing in the background, by the way. He said that we would have something that would allow us to speak with people who are far away and see their image at the same time. He basically predicted Skype in 1882 and imagined it would look like this. And we had another person who spoke French, Le Corbusier, who was actually Swiss, and that was his full name, Charles-Édouard Généré-Gris. And he was an architect who gave us this. Now, you might be looking at that and think, what's special about that? This is exactly what any ugly city in the Soviet Union or China looks like these days. And that's exactly the point. He came up with the idea of building cities in this way when no one else had ever heard of this before. So Le Corbusier is the guy who gave us the big ugly cities that we now see in Russia and China and parts of Europe and the States and South America as well. And his idea was to build cities that could house millions of people in the future when there would be millions of people in each city. That's one thing to consider, that in 1902, there wasn't a single city in the world that actually had as much as 1 million people. So he was clearly thinking ahead there into a time that is more like ours with lots of people in it. And he figured that if you're going to be building cities like that, it would have to be built for cars as well, because everybody would have cars. Now, at the time, he was considered a bit of a nutcase, but as we see now, this could absolutely be just a boring drawing of some place in China or maybe some suburb in Brooklyn. So got it right. And he went on to be more successful, and he started building the world's first proper high-rise residential building. This is the Cité Radieuse, the shining city in Paris. And he imagined that everybody who lived there would be really happy to be so close together, and they would do all sorts of jolly things together living there. We know now that that doesn't exactly work, and that people who live in these kinds of places are not likely to do those kinds of things with each other. But how could he know, right? And these are propaganda photos from the time when it was first built. He came up with models also of how a city for millions of people could look. Like I said, at a time when there weren't any cities for millions of people. And again, people said, oh my God, this is like way out there and probably never going to happen. And then we're looking at Shanghai. This photo is from 2015, and we have a pretty good mirror image of that, right? I mean, Shanghai has now 25 million inhabitants, and they're clearly adopting his concepts for a city that has to house many millions of people. It just makes sense to stack them like in bookcases, which is what these high-risers are. And as for the cars, well, he was a bit ahead of his time there in 1902, but only 35 years later, the Volkswagen Beetle actually came along, and he had it remarkably right with regards to a lot of things that make sense with cars. Notice the big front bumper here. So this is clearly trying to be a safe car. And it also was trying to be drop shaped, which was considered to be the most aerodynamic shape at the time. It took another few years until a man named Wunibald Kamm came along and realized that it's okay to just chop your car in half, basically, without ending in a pointy teardrop shape, and it's still aerodynamic. So that's why our cars today don't have a long tail like that, but look chopped off. It has the same aerodynamic effect. That's something he clearly didn't know. But he was really spot on with the idea that if you're going to have a city for millions that will require a car, it'll have to be a small car. And if everybody drives it all the time, it'll have to be aerodynamic so that it doesn't consume too much fuel at high speed and so on. Not bad. So what is the skill that is required to get these things right? I mean, these people were clearly living in a totally different world from the world that they were predicting. And still, and they got it pretty much right. But we have, I've gathered here a few interesting quotes from people who have always been visionaries and done a good job predicting the future. Arthur C. Clarke, you may have heard his name, is the man who wrote Space Odyssey 2001, amazing film that is not from 2001 at all, but I think from 1968, isn't it? So well made it could be done today. And he wrote this wonderful thing here. Any sufficiently advanced technology is indistinguishable from magic. Now, as a designer, I would say you could turn this around and say, if you're going to make something new, if you're going to introduce new technology and a new solution to society, aspire to making it seem like magic. You know, you want somebody to look at your solution and go, I can't even figure out how this works. That's cool. And then you've got something that will be like from the future. Gene Roddenberry, the guy who wrote Star Trek, the original Star Trek, had this very interesting thing. He said, in a better world, I can do anything. And with that, he probably meant that if you're going to be describing the future, which will hopefully always be a better world, you should envision a world in which anyone is able to do things that are hard for us today. So that's one way to predict the future. If it's difficult today, well, in the future, it should be easy. Then here comes Jules Verne again and says, anything one man can imagine, other men can make real. And this is just men, of course. This is just a thing with the English language. We mean people here. So if someone can imagine something, even if they don't know how to make it real, someone would probably one day be able to make it happen. So don't be afraid of dreaming big and wishing for something to be a reality. If you don't know how to make it real now, don't worry. One day somebody might. Record the dream. And that's pretty much in line with what Einstein also said. This I found very interesting. He says that imagination is more important than knowledge because knowledge is actually limited and imagination is not. So I think that's very deep, because if you're working with people who always go, yeah, we don't know if that works. Yeah, we don't know if that is correct. Nobody has done this before. This isn't proven. Then you are working with a bunch of people who are drawing from a very limited pool of possibilities and resources and experiences. But if you're turning it around and if you're saying, right, I'm going to imagine something now that doesn't exist, and I don't care if no one has ever tried it before, it's what I want to happen. And we'll look into how that can be done later. Then you've actually created something. Then you've created something that goes beyond the present. And that's pretty much how the future is made. So with all these thoughts here, I've been thinking, is there a recipe to be able to predict the future. And I think there is actually. Now, I'm an industrial designer, which is pretty close to being an engineer, only that we look more into the human aspect of things and stuff. So let's take an example here. Let's say we are being put in charge to develop something that makes hot water. Now, the logical thing that somebody with a conservative mindset would do is they would say, right, we'll make a water kettle. But think about it for a moment. Why do people actually want hot water? They make tea, right? Or something like that. So this isn't about making a water kettle. This is about making something that makes hot water. And maybe there are other ways to make hot water than with a water kettle. I'm of the opinion, for example, that we could totally have cups with a small microwave device built in that can just make 1 cup of hot water. Why do we need a hot water kettle these days? And of course, that would seem like magic then. You have a cup and you click a button or touch it in a certain way, and woo, before you know it, the tap water in it is hot water. I think we could have that. So maybe the recipe for getting something ready for the future is a bit like this. First of all, always know what kinds of technologies are coming up. If you want to know what they are, there is a wonderful thing on Wikipedia called List of Emerging Technologies. It's constantly updated as researchers the world over are adding the bits that they've discovered. And you know what people are working on just by going through that list. I think that's the number one thing to do if you're going to be in research and development as an engineer, as a designer. You need to know what emerging technologies there are in the world, what's coming at us in the coming decades, so that you can be ready for it. You also need to be very realistic about the world you live in. So any emerging issues you need to be familiar with. We know, for example, that we are going to have ocean levels that will be at least 1 meter higher than they are now by the year 2100. We may not be there at the time, but even before it reaches a meter, things are going to start happening around the world. Rivers are going to start going over their boundaries because of the increased water levels and so on. So there will be issues for which there will be solutions, and we need to be the people who provide these. That also means you always need to keep at least a critical mind about the current solutions. And I'm not saying discount all current solutions. That's not right either, because many of the solutions we have now will continue to be good solutions in the future. Just be aware that some of them may not be. Some solutions will eventually just be old and no longer relevant. You need to know which ones they are before it happens. So always believe that there is a better way and that you can create it. And that should enable you to at least be ready for a future as an engineer and creator of new content. So as I said at the beginning, the thing to keep in mind is lead time, and to work with lead time. Lead time is that time frame that we have between the start of the project and its implementation as a product. If we look at the whole process of a project from start till product launch, we are basically looking at a thing that looks like a train track. So we have the past, the present, the future, and it travels that way, right? That's the only thing we have on this planet. And now let's say we are the people who are in the process of designing or creating something, then we are working with that flow, where we always need to keep in mind that as we work on it, it's beginning to get older. So we need to be aware that our product is going to need to conform to the requirements of the time that will be there when it gets launched. So it's not a good idea to look at the present and how things are done now when you're creating something. You need to look at how everything's going to be by the time that product hits the market. Now, I've been looking at methods that are actually used in industry and in science to predict the future or to forecast. Forecasting is in itself a skill and a job descriptor, actually. So if this kind of thing interests you, you might consider getting into that. And I've found these 6 different terms here that are used as hard-lined things that are respected in industry. Now, let's say, for example, that we want to predict what the future has to say about Elvis Presley and the music of Elvis Presley. Now, we could use a thing called the informed opinion. The informed opinion could work like this. We know a few facts about Elvis. We know, for example, that the copyrights on his songs are going to lapse about 10 years from now. That means they're no longer going to be protected by copyright. And that means any radio station that wants to use them can just do so, no charge. And that could mean that they play more Elvis, and that could mean that Elvis will become more popular again because people hear it, maybe like it. And that means that there could be more Elvis impersonators. You know what an Elvis impersonator is, right? That's a person who acts and looks like Elvis Presley. And so I think that is a fair way of forecasting that there are going to be more Elvis impersonators eventually. We could be a little more mathematical about it and say, okay, on average, and this is the average approach, on average, there have been around 6,000 Elvis impersonators in operation worldwide every year since 1960. So this is an average, right? The real number might have fluctuated wildly from, say, 2 to 50,000. But if we just use this average value, we can pretty much predict that by the year 2050, there should still just be 6,000 Elvis impersonators in operation worldwide, because there have always been 6,000 Elvis impersonators in operation worldwide on average. So we can use an average value. That has its limitations, as you'll agree. I'm sure you already have 10 doubts in your mind, and that's good. So what we can do instead is slightly better, I think, is an extrapolation. There we're actually looking at the dynamics of a development over time. And when we look at that, and this is perhaps where the average has come from, we know that initially there was only one Elvis impersonator. Only one other person, while Elvis Presley was still alive, thought it was cool and a nice idea to imitate Elvis. So there was Elvis and there was a fake Elvis in 1960. By 1980, 20 years later, 2,000 people had caught on to that idea and did the same thing, earning money as someone who imitates Elvis Presley. And today we have 6,000. So therefore, if we just continue on that curve, there should be 80,000 of these people by 2050. You'll agree, this is completely bonkers, but that's how it works. And it works with a few things, maybe not with Elvis impersonators, which I'm using as a bit of a joke here, of course, but that method works. You're looking at the dynamics of something and you're just continuing the curve. Another thing we could do is that we do a so-called trend estimation. With that, we're looking at the general dynamics of how it's been going. So we're no longer caring about the average or exact figures, but we're looking at just how much more or less popular has Elvis Presley become over time. And there we see that actually Elvis Presley has become less and less popular since 1990. So it's probably not entirely unreasonable to expect that that will continue and that he's going to be even less popular than today in 2050. Now that contradicts the first one, doesn't it? So many of these methods will contradict each other. That's a bit of an issue with it. That's what we have. You can also forecast based on technology. And that's where that list of emerging technology comes in a big way. What I'm trying to say with this here is basically that if you know that a certain technology is going to be widely available in the market at a certain time, then you can predict that is going to influence the world in a certain way. But we could say here, for example, that we know that holographic technology is coming up. Now, as soon as holographic technology is coming up, people will start looking for things to do with it. And I mean, what can you do? You can put up some holographic displays of someone singing and dancing. And well, Elvis is one of those people who sang and danced really well. So it might be nice to see more of him holographically, and that's likely to happen. Or we do a thing called pattern recognition, which is often also used in meteorology and in marketing. And when we're looking at that, we see that actually it seems that Elvis Presley has been coming and going in his popularity in a certain pattern. He has always been a lot more popular around Christmas than in the summertime. And that is likely going to continue in the future as well. So there we have it. These are the methods that are available to us that actually are recognized and don't make us look entirely mad. And then we need to look into justifying that change that we're bringing about as engineers and as designers. Because why should we change stuff, right? Now, here we're going into a thing called innovation methodology. And we're looking at 4 different ways of bringing about change and justifying change to our colleagues, to our industry, to the world, if you will. One is a thing called the inarticulate need. And that in itself requires future forecasting, because inarticulate need means we're talking about a need that is coming up in the world that nobody sees coming. Nobody but a few experts and specialists know that a need is coming. Now, to give you an example for that need, let's use an electric car. I predict that one of the biggest inarticulate needs of the coming 10 years is going to be more coffee because of the electric cars. And it's very simple. When you drive an electric car, you need to recharge that car quite regularly. And if you're doing long distance driving, then, well, probably every 200 or 300 kilometers, you're going to pull into some sort of station and recharge. And the shortest charge you can do that means extra range for you is still about 20 minutes. Now, what do you do when you have 20 minutes and your car is charging and you can't go anywhere? Do you just stand there? Or do you perhaps have a cup of coffee, as people who drive long distance like to do every 2 or 3 hours? So the more electric cars we're going to see, the more people will be having coffee by the wayside as the cars are charging. It's inarticulate need. We have the opposite as well, the old customer need. We can predict very safely that the police is always going to need fairly heavy, fast pursuit cars that can perhaps do well in the snow, so they need to be 4-wheel drive. In short, we know what the police needs. Their needs are not really going to change a lot in the coming years, so we can predict what the police needs. They are an old customer. And then we have the market needs, which can also help us predict the future. When I lived in India, for example, there was this weird thing where you could walk into a convenience store and buy a single roll of toilet paper. They would just have them sitting on the shelves. And then one day I came into that convenience store and all of these rolls were packaged one by one. And that was a market need, because people didn't want to buy toilet paper that had loads and loads of Bangalore dust on them. They wanted clean toilet paper. And that was a market need that eventually spread to all sorts of other products in southern India. And you saw people buying things in wraps that they previously hadn't. Previously, you could actually buy snacks and things that were not packaged in India. Now, suddenly, with the wrapped toilet paper, they also wanted all sorts of other things wrapped. And that's simply a market observation based on which you can predict the future. And now that we've talked about innovation for a second there, I should probably bring you this matrix, which shows you the 4 different types of innovation that are part of our vocabulary, really, as developers. The first one that you would see most often is a thing called sustaining innovation, and it has nothing to do with sustainability. But to sustain means to maintain something, to keep going with something. And you most frequently see this in the car industry. You will have a new car coming out and it has the same name as the previous one, but it has a slightly different body. It may have a slightly different engine. Everything's updated a little bit to keep the car current and interesting and relevant to the needs of the consumers. So that is called sustaining innovation, when we're basically just making something a little better so that it can stay in the market and maintain its place there. The next thing we have is a thing called the disruptive innovation. So disruptive innovation means we are actually making a bit of a bigger change, even though we are keeping the kind of product that it is. We see this right now with the car industry. The car industry is going through massive disruptive innovation by going from petrol-powered cars to electric cars. So that's a disruptive innovation because we are actually changing something about the product in a big way. Something really massive is happening here, but we are continuing to make the product. Strangely, perhaps, research also counts as innovation. That can be a bit odd until you look at things like these. I'm not sure about engineers, but we industrial designers and car designers often create concepts for public display. And this is mostly to check the reactions of the public. So we are taking these to the big car shows in Frankfurt, in Shanghai, in Geneva, in New York, just to present it to the public and see what the public says. We say, well, guys, this is the future. How do you like that? So it's a way of innovating because we are basically saying this is the new world of cars that's coming at you. And it's also research because we're using it in order to find out how mankind likes it. So in that way, research can also be innovation. And then we have this, which is of course thought of as the crown jewel of innovation. This is the so-called breakthrough innovation. Breakthrough innovation is when you have a much better idea than anything that we've been doing so far. And if we stick with cars as an example here, we could say, okay, as soon as somebody comes up with teleportation, like at Star Trek Enterprise, where you're just beaming people places, then that's the end of the car. Because who will want to drive if you can just step through some arc and bam, you're in Thailand? So that is a breakthrough innovation, and that would be like the top type there is. So now you've seen an innovation matrix also to be able to predict how to act on your future predictions. Let's get pragmatic and see how you can actually do this yourself. I mean, all these methods need some training and stuff, don't they, and gear? But you could actually do things directly, even now, at university. You could spy on your rivals and on your competition when you're working for industry. You might have seen these guys. Some of these images are from Arjeplog here in northern Sweden, because the car industry, and we're saying the entire car industry of the world, is actually taking their prototypes for testing to the frozen lake of Arjeplog. So you can sometimes see them driving up the E14 And I've seen lots of Bentleys and Land Rovers and things going up there. And you actually have people like that, photographers who are lurking in the bushes with long lenses of their cameras, trying to snap photos of cars. And they then sell these photos to the competitors. So these images here of Mercedes and Audis, they've probably gone to Toyota and to Mazda and Hyundai and so on. So these people are, it's not entirely industrial espionage, but clearly they're photographing prototypes. And that is why these vehicles are camouflaged the way they are, because the industry doesn't really want the competition to understand entirely what they're building. But this is happening to be able to predict what the competition is doing. And it's a benchmarking thing. Another benchmarking thing that goes on is trade fairs. This one is perfectly legal and doesn't require anyone to hide in a bush. Big trade fairs where companies that are auxiliaries of industry are presenting their capabilities. So I think this one is somewhere in Birmingham. I got that from there. Yeah. So you see all these different companies showcasing what they can do. We have one company that does a certain kind of rubber clip. You have another company that does a certain kind of metal treatment, and they show what they have there. Now, you know, if somebody's offering it and it looks like a good idea, somebody's going to be using it. And so you can tell that that's going to be used by some people. It's a subtle way of predicting the future. But, you know, if you're the guy who's in charge of doing the rubber clips somewhere, you'll want to know about those rubber clips because they're coming. Another super easy and convenient way you can do from your couch is to search the patent data banks of the world. You can basically just surf the patent offices of the world, reading page by page what your competitors have patented. And I mean, clearly, if your competitors have patented a technology or a process, well, they have done that because they want to use it. So if a new patent has just been published in the name of your competitor, you can be pretty sure that they are planning to use that. So that's another way of predicting the future. And they don't always have to be patents in the patent offices. You have places like this vault where free patents can be had. I think Toyota and Tesla have just started doing that. They're giving away their patents. They want people to use their inventions because as soon as a lot of people are using their technology, obviously the infrastructure gets built that is required for their new technology to be more widely adopted. So you can actually see a lot of upcoming technology on websites like these that show you free new patents that can be just grabbed by people. So that was option A, spying on your competitors. Now, option B would be to just become a little more analytical. And that would be when you're using these 6 techniques that I previously showed. So we go through all of this. What do we actually know? Coming technology, the plans of our rivals, maybe changes in legislation. Then the question, how has it always been? Is there a dominant design like Kleenex for paper tissues? Absorptive capacity is a wonderful thing. It describes just how ready your customers are to accept a new technology. That's called absorptive capacity. How ready are people? What are the old customer needs? We're talking about the police here, right? What do they always need? That answers the question, how have things traditionally always been? Or we extrapolate. That's the one with the curve, you remember? What if things continue as now? We just do some performance benchmarks, how things have been getting more and more powerful. We know, for example, that the Toyota Corolla has gained on average 10 horsepower per year. Well, that's probably going to continue. We look at the criteria that are required to be able to extrapolate in the first place. And then we're looking at what all the companies that are working with our company are actually capable of. Yeah, that's the one with the trade fair where we're looking at the rubber clip people. The trend estimation we have already looked at. That is where we are looking at developments in other fields that are related to ours. We are looking at how our customer base may change. You see that in the case of Renault, for example. A French company, Renault, has started naming their models in ways that sound a lot more Middle Eastern than they used to, because they know that the customer base in the Middle East is getting wider. So they should have model names that can be pronounced by someone who speaks Arabic. We may also know that laws may change. Yeah. We know, for example, that the Germans are going to require solar panels on your house roof if you are a house owner by, I don't know, 2025 or something. So all this stuff tells us how the future will be. We can also look at research publications, which is brilliant. Maybe you've heard of Google Scholar. That's a corner of Google that very few people know about, but you can find all research papers that have ever been written on Google Scholar. So if you need something written by a scientist, that's where it is, and it's Googleable in all convenience. Patents, like we have already looked at, and then the trade shows we were talking about. And then there's an interesting thing called the technology S-curve. The technology S-curve is something that every product goes through. Basically, you can say this is about the life and death, or the birth and death of every product. Every product spends a certain time of its life young, and then it becomes mature, and then it becomes old, and then it dies. And hopefully before it dies, your company has found something to replace it with, because otherwise you're left with nothing. So you need to know what the technology S-curve of your product is. Where is your product now? Does it require a replacement soon or not so soon? You don't want to replace something too soon, otherwise you'd have wasted the time and effort and the money of the previous developers, right? And then there is another interesting thing called the punctuated equilibrium. I'm just introducing all these terms to you now because this is the kind of stuff we work with in development. The punctuated equilibrium basically describes the dynamics between something gets discovered and something gets understood, and then something actually gets launched as a product. So there is a chain of actions that needs to go on from the first to the last point, and that's called the punctuated equilibrium. So if somebody discovers something wonderful, like translucent aluminum tomorrow, then it'll be a while until we understand how we can actually make it reliably and cost efficiently in a factory. And then there will be yet more time until people are ready for it, until it can be marketed, until we have somebody who buys it. That's the punctuated equilibrium. And then obviously we have this thing called design research, which is probably no different from engineering research, it's just research. There, this is it. So the question is simply what will be required or valued, and then you forecast your emerging needs and values. I think that's pretty much the recipe for doing forecasting and predictions in industry. This whole thing here. So if you ever needed a recipe to predict the future as a professional, I would say use this page here. This should work. Now, what actually will the future bring then? Can I tell you? Not really, because the future is a many splendored thing with a lot of different aspects, but you can decide on some of the aspects that are going to be the future. And then there will, of course, be decisions that will be made by others, and there will be chance events. So we can only say that there is definitely going to be a future, and some of it will be of your own making, but the rest of the future will be made by other factors, other agents, and events. And that's all we know about this. So I hope this will be useful for you in the future. And we stop the recording.